We're going to convert the point with Cartesian or rectangular coordinates -3, -5, 3. We want to use positive values for both r and theta, and we're asked to round to 2 decimal places if needed. So because the given point has Cartesian coordinates, we know x equals -3, y equals -5, and z equals 3. To find the cylindrical coordinates, we'll need to find r, theta, z using our formulas here below. But for a quick review, r, theta is the polar representation of a point in the xy plane, where r is the directed distance from the origin in the xy plane, which should be this distance here. Theta is the angle counterclockwise from the polar axis or positive x-axis in the xy plane, pictured here. And finally, z is the directed distance up or down from r, theta to the point, shown here. So going back to our example, let's first plot the point -3, -5 in the xy plane to help visualize r and theta. So this is the x-axis, this is the y-axis. Since the x-coordinate is -3, we'd go left 3 units. And because the y-coordinate is -5, we go down 5 units. So this would be the point -3, -5 in the xy plane. And therefore this distance here would be r, and angle theta would be any angle that terminates along this side. But since we're looking for a positive value for angle theta, the least positive value for angle theta would be this angle here. We could also sketch a reference triangle if we wanted to, where these would be the two legs of the reference triangle. This leg would be -3, this leg would be labeled -5. Notice how to find r would use the Pythagorean theorem given here as r squared equals x squared plus y squared. So we'd have r squared is equal to -3 squared plus -5 squared. So we have r squared is equal to 9 plus 25. So r squared is equal to 34. So now we take the square root of both sides of the equation. Notice how we'll have two solutions here. R equals plus or minus square root 34. But we are asked to use a positive value for r, so let's go ahead and use the exact value of square root 34. Notice how we do have the option here of rounding to 2 decimal places. So if we wanted to, we could express r as approximately 5.83. Now let's determine angle theta. We know tangent theta is equal to y divided by x, so here we'd have tangent theta is equal to -5 divided by -3, which equals positive 5/3. So if tangent theta is equal to 5/3, then theta is equal to inverse tangent or arctangent of 5/3. But we might recognize here that the output of inverse tangent is only going to be on the open interval from -π/2 radians to +π/2 radians. So the calculator is not going to give us the angle theta we're looking for, but it will help us find our angle theta. Let's first verify we are in radian mode, so we'll press the mode key. Notice how radian is highlighted, so we'll go back to the home screen, press second tangent, 5 divided by 3, close parenthesis and enter. If you run out 2 decimal places, this will be approximately 1.03 radians, which should be in the first quadrant. Our angle is in the third quadrant. But let's go ahead and sketch this angle. The calculator gave us this angle here, which is approximately 1.03 radians. So while this angle is in the first quadrant, it does tell us the reference angle in the third quadrant. The reference angle here is approximately 1.03 radians. So to find the angle we're looking for, we'll have to add pi radians to the reference angle of 1.03. So 1.03 plus pi gives us approximately 4.17 radians, which is the angle theta we're looking for that terminates in the third quadrant. So we found from the calculator the angle theta was approximately 1.03 radians, but to find the angle in the third quadrant we had to add pi radians, which gave us approximately 4.17 radians. And the z coordinates are the same in both cylindrical and Cartesian coordinates. So z is equal to positive 3. So here's one possible way to express the given point using cylindrical coordinates. I hope you found this helpful.